My name is Luciano Resende. As Paco said, we're from the Spark Technology Center. We just announced it yesterday. We are rebranding, so now we are called Code, which is a... Sorry?
Can't hear you.
Just step up to here.
Can you hear? Better? Okay. So we just got renamed, so we're now being called Code, which is a Center for Open Source Data AI Technologies. So we are basically expanding the scope and doing more things more towards AI. I think that is a trend that we are seeing in the industry, so that's kind of like where we're going. I've been working with open source for lots of years, more than 10, I guess, and have been doing a lot of like Apache stuff, and recently migrating more towards like data science infrastructure and based on Jupyter. If you need to connect me, here are all the information. It's going to be available. Just reach out.
Hi, my name is Kevin Bates, and I too am a colleague of Luciano's at the Spark Technology Center, or the Code location. I've been in the enterprise software space for my whole career, over 30 years. However, I'm relatively new to the open source and Jupyter framework, so this is a good learning experience for me, but also I feel like I can add some insight from an enterprise perspective to this environment. So again, there's my contact information, and I'll hand it back to Luciano and talk to you in a minute.
So I think we're going to divide this talk like in 3 pieces. We're just going to go through a couple of slides where we just want to make sure everybody get on the same page. I know most of you knows Jupyter, but because we're going to be talking about the infrastructure, we're going to go a little bit more details on that. Then we're going to talk about Enterprise Gateway, and then the actual demo that we're going to do and how we build that. For those that are new to Jupyter, I believe very little, you guys. But what Jupyter brings to you is like an interactive development environment that allows you to start adding your code and adding surrounding information to that, basically where you can document, being very interactive, enables you to have plottings of your data so you can have insights and a lot of tools all available on that environment for you to start building your algorithms, your applications, and getting insights of data. When we look into the architecture and how all of that work, we see mainly 3 pieces here. You have your browser where you actually see the UI that is being served by what we call the Jupyter server. But then when you try to execute code, we have what we call kernels, and kernels is an abstraction which is responsible for executing code and gives you kind of like understands the language that you're using. So you have a kernel for Python, you have a kernel for Scala, and so forth. We have, I think, over 100 kernels available today, and they keep growing. In terms of like how they communicate, this is kind of like a more breakdown of the architecture. You have the notebook server where it takes care of the communication with the kernels. You have the kernels running on a separate process, and they will be communicating by what we call the socket ports, which is part of like the kind of like the protocol that is using for communication. We have 5 ports that are used, and each one have its own kind of like responsibilities, and we're going to be talking about some of those in the next few slides. For doing the communication, they need to kind of like know what port to connect to, and a couple of other informations on how like to sign those messages and things like that. And Jupyter has this notion of like connection profile that will have the information necessarily so that the server can connect to the kernel. Most of the time when you look into Jupyter in itself, they are kind of like bounded into the same machine local process, but we're gonna talk a little bit about also having the ability to have remote kernels. So I mentioned about the ports. Here are kind of like a little bit of what goes on each port. So you have like a shell port where you start sending requests. IO probe is kind of like to communicate back some of the results. You have the sender input, like if you need to pass input for the kernels. Control is most likely for sending control commands, like if you want to do a shutdown, interrupts, and things like that. And heartbeat monitors if you have your your kernels is still up. Otherwise, Jupyter will try to restart the kernel and things like that. And when you actually execute, try to execute a cell, kind of like this is what you're going to see. You have a flow of messages going on. But the only thing I want to mention here where we're going to use later on is you can have two types of results coming back from your requests. So if you're doing like a computation, like for example 1 + 1 or something like that, you get a result back. But if you're doing kind of like a streaming where you're doing like a print or you have like a large data set and you're just streaming some data, that is going to come like in multiple batches as what we call streaming. And that makes a little bit of difference when we programmatically trying to communicate and talk to the kernel, which we'll see a little bit later on. With that, let me pass to Kevin. He's going to talk a little bit of like an enterprise gateway.
Thanks, Luciano. So I wanted to come back to this slide and point a couple things out. One is when we're doing analytical processing, especially in a Spark environment, the kernel Python process, or the kernel process, is what's known as the Spark driver. And Spark drivers have a tendency to consume lots of resources. In addition, the current design of this architecture is that it's geared toward a single server environment. So you got your notebook server and your kernels all running co-located. That presents some challenges in an enterprise-wide space where you want to have lots of kernels running for lots of users, and so we kind of get bogged down, especially if it's doing heavy analytical processing. It can kind of take your server, consume too many resources on the server. So one of the things we wanted to do with Enterprise Gateway is, and we'll get to what Enterprise Gateway really is, but we found that in IBM, many of the product groups were embedding Spark on Yarn. So there was a big embracement of Spark across the product space at IBM. And they all wanted to use Jupyter Notebooks in this space. And so that presents the challenges, and these are enterprise applications. So you have your enterprise tenets of multi-tenancy and scalability and security to be addressed. And we felt that the way things were right now, we couldn't really address all those aspects appropriately. Some groups tried to scale up their notebook server to support multiple notebooks, but then you get into multi-tenancy issues. Others tried to launch per user notebook servers, but then you get into scalability issues with that. But one thing that resonated across the administrators and developers at IBM was Jupyter Kernel Gateway. And what Jupyter Kernel Gateway brings to the table is this notion of a bring your own notebook. And so you can essentially remote your notebooks and get the notebook files that the data scientists are using off of your enterprise servers. And that's a pretty compelling thing to think about. So it solves some of the issue. You get some of this stuff off and you let the commodity server drive the notebook. And they do this through the WebSocket personality. And so by adding the extension, this MB2KG extension, which is Notebook to Kernel Gateway, into your notebook or Jupyter Lab, it all just works. You're essentially remoting your notebook to your enterprise servers. So that's one thing that we felt we needed to build upon. So we did some prototyping with Jupyter Kernel Gateway. And we were able to push our notebooks off the servers. We have Bob in blue and Alice in red. But we still ran into issues. We still didn't really solve the real enterprise issues that were happening. And as you can see here, when you go to hit Kernel Gateway, your kernels are still co-located with the process that's launching the kernels. And so your Spark drivers are still consuming the resources of a single server. Yeah, you get your workers out in your Yarn cluster, but really the heavyweight resources are still pinned to that one server, and that wasn't a good thing for us to deal with in the enterprise. The other thing is your Spark jobs are all running as the gateway user, the service user that launches that the gateway is associated with. And that's not a good thing either. You don't have any sandbox control. Bob could go bang into the shell and see Alice's processes, and likewise for Alice and It just wasn't a good thing to even send out in an enterprise capacity. So as you can see here, this isn't a scalability diagram that you'd want to take home to your mother. This just isn't going to fly. You're completely gated by the kernel gateway server as to how many kernels you can launch. That's not going to work. No bueno. So we set out to build Enterprise Gateway. And so we had some initial goals, the three being to address scalability, multi-tenancy, and security. And so we knew we wanted to leverage the capacity of the resource managers. So we focused on Yarn initially. And by launching the kernel as a Yarn cluster application instead of a client mode, we let Yarn determine where that kernel is going to land. All right, so now the kernel is running off on some worker node somewhere, and we've established a way to communicate back with that kernel. So now we're talking to a kernel in a remote format. So as we implemented this, we knew we wanted to plug in other resource managers along the way, and we've got a couple more that are coming soon that we're really excited about. And in doing so, we've essentially built a general framework for remoting kernels. And I think this is going to be very helpful in the enterprise space. Now, by leveraging Yarn, one of the primary ways security is addressed in these Yarn clusters is through Kerberos. And so by Kerberizing your Yarn cluster, we can take advantage of Spark's proxy user flag and actually launch the kernels in impersonation. So we're impersonating the users for each of the kernels. That's establishing isolation at a user level. But also because HDFS is ingrained in this ecosystem, we can also associate each of the kernels with an HDFS home foldering, and we get the file downloads and stuff per HDFS and some sandboxing capabilities with that. The user ID now is Alice, and for Alice's kernels, and it's Bob for Bob's kernels. And likewise, if they were to do a batch job, they would also see in the Yarn management UI, they would see their jobs associated with their user IDs, so administrators are able to decipher whose job is what and whose job is taking too many resources and needs to be terminated. In doing so, because the kernels are now remote, we needed to secure that communication between the kernel and the gateway server. So we do that, as well as any front-end security concerns that come in from the front side. So as you can see, we're built right on top of the Jupyter stack. So we derive directly from kernel gateway, and we kind of reach down and override some of the kernel management functionality in both Jupyter Client and in Notebook. So with that, we're all part of the same group, and we've essentially Enterprise Gateway is essentially a remote kernel manager. It's really the core of the code that's in Enterprise Gateway with this pluggability to plug in different resource managers. So here's that diagram before, but now we have Enterprise Gateway running. And as you can see that we've still got Bob and Alice off remoting using MP2KG to get to the server. But now the kernels are running across the worker nodes and running as the users that they are intended to be running as. So we get the sandboxing, we get the user isolation, and we've removed the heavy-duty Spark driver resources off of our gateway server, so it can be lessened from a resource perspective, and you can focus on the worker nodes as being your resources. So here's that same scalability graph. It's a little bit better. If we needed to add more kernels, we can just add more nodes, and we should expect to see that kind of increase in scalability. This is one that you could take home to your mom if you wanted to. So here's that original diagram that I started the talk with, but we've done a couple things here. We've inserted Enterprise Gateway in the middle here, and then I've color-coded where you could have division of nodes. So we could have our kernels running on a separate node, enterprise gateways in the middle, and then your notebook server is really off on your desktop now, and your enterprise machines are what are servicing the kernels, which is where most of the work is happening. So with that, I want to hand it back over to Luciano, and he's going to talk about the analytical microservice that we developed for this presentation. The moment you've been waiting for.
Thanks, Kevin. And I think you guys now have an understanding of like a lot of like the things that we're going to be using by building this enterprise gateway. The socket personality give us a little bit simplified environment for managing the kernels. It also gives us a scalability so we can run more kernels in a distributed environment. But let's take a look at like what is all about building the microservice. So let's start with kind of like a use case that we kind of like took as an example. We wanted to work on like a real data, so we were looking for kind of like what data set we could use. One of the things that we found out is like there is this Yelp data set from Kemel, which basically has the business, has like reviews from those business and a couple of more information. So we decided to do some example with that. We wanted to calculate the sentiment, so we use Affine. I don't know if you guys are familiar with that, but there is a library in Python that can help us calculating the sentiment. And Affine is kind of like, I think, a big dictionary with kind of like scores for those words in terms of like sentiment, and that is used to calculate the score for kind of like what we are using. We are using PySpark for like a training and doing data manipulation and things like that. And we are using the Jupyter Kernels to really like interface and give us the flexibility to easily connect back to a cluster in a very simplified way. In terms of like components, what you're gonna see in the code, we have kind of like the front end. The front end is gonna be any client that can talk to REST. You can be using as a part of your like solution where you're building aggregating multiple microservices. You can just maybe connecting from a curl command or you name it, like a web app or a mobile app. So we have a sentiment resource. In this case, we are leveraging Flask to handle some of the kind of like resource exposition for us. We then created a sentiment provider that kind of like goes into just like being able to the logic around the sentiment. And we created a quick utility that wrap all that communication, so like knowing how to start, how to stop kernels and things like that. And we'll go into more details in a little while. But then on the right side, kind of like on the server side, we'll be launching kernels remotely and all in kind of like a Spark cluster here. So let's take a quick look into kind of like initial things. So the first thing, we want to be familiar with the data. So nothing better than using Jupyter notebooks. So we use that just to kind of like load the data, play a little bit with that, do any kind of like manipulations that we needed, or just to get familiar with the data. And so this is what kind of like the only very little things that we did. One of the things just for the purpose of the demo, we filtered a little bit the size of like the scope of the data, so it could be easier for us to like be iterating and not having to wait a little while to get this data processed during kind of like development. So the sentiment REST API, we can take a look. On the right side, you will see mostly of the code here. You can see it's very simple. It's based on Flask, Flask RESTful. And what you need is you define like a sentiment resource class, and you have like what do you want to do when you respond to, when you get a call, a request on that URI that you're exposing, and that logic is incorporated there. And then you just tell Flask like how you want to expose that. So the REST API is basically sentiment / and you can pass a parameter, which is kind of like which customer or which business you want to retrieve kind of like the sentiment for that. And when we are kind of like bootstrap the server, we kind of do kind of like the start of the kernel and stop. Sorry, just the start. In terms of like the sentiment provider, that encapsulates all interactions with the kernel, so it knows like what commands it needs to send for the kernel. Imagine this like things will go in the cells of the notebook, so the logic behind of like how to calculate the sentiment. And the most important thing here, you will see kind of like towards the bottom, is mostly like how we actually integrate the Spark to calculate on the fly, kind of like the new column from the data frame, and put the sentiment for that review there. And we're actually doing this when you do the invocation, so you can get like the latest and greatest information available. We also created like kind of like two classes for helping dealing with the kernel. We have a kernel launcher that has methods for starting and stop the kernel. The way you do this with like the APIs that are exposed into Jupyter Kernel Gateway and Enterprise Gateway, basically there is a call, a REST call that you can invoke, and that you will start the kernel for you, and then there is another one that you, based on the kernel ID, will stop that kernel for you, and we have encapsulated that. And what it returns back in this case is kind of like a kernel object, and the kernel object then knows how to send code. It will, you basically call eval into a piece of code that you will have, like let's say in your cell, and we send that to the kernel. We then look into all those socket messages that we are receiving back, so that we aggregate the results that are coming and send that as a return, and that gets flowed all the way to kind of like the REST, whoever is consuming that REST API. So right now I'm just starting the resource. This is basically my logs. You can see that we are having the kernel started.
This is on the Enterprise Gateway server, this blue log.
Yeah. And we see here on my console here what codes we are sending. And basically when we start up in the resource, you can see that I'm basically loading the data so I can then have the sentiments scored. And if we go now to our kind of like front-end UI, so here is kind of like just a very simple web page, and what I'm doing on each one is basically each of these links invoke one of the REST calls for a given business, and you will see that then data is being sent there. We are doing the lookup for that business at that moment, and also calculating the sentiment and what you get back. So we got the business details, so we know like which business you requested, and we get for each sentiment we get a score from Athene of like what actually the sentiment is. And we wanted to make this kind of like just a real scenario, mostly like as an example. I think the idea is like you can start building adding kind of like analytics capabilities to your application in a programmatic way, and exposing that as REST, or just if you're just building an application, integrating that and leveraging all the power of kernel, all the power of like the Jupyter platform to be doing some of this interactive development and getting analytics and insights from your data. I think that's most of what we wanted to get with you guys today. Let me just go back to slides where we have some additional information. So further readings here, just if you guys are wanted to get more details. So two things, if you, for example, want to have the requirement to connect directly to the kernel, there is a couple of other things that you can use here. You can use Jupyter client, but also I've done a Tori client, which in the past, which is very similar to what we did today. It's just that instead of like going through the personality, we actually go directly to the kernel with talking directly with the 5 ports. Also, we have another type of personality exposed through JKG, which is kind of the HTTP personality. What that gives you, it's kind of like launch the gateway into like a single notebook mode and expose a REST URI for kind of like each cell of your notebook. So that's probably another way that you can think about exposing some of your analytics. And we are open source project. We welcome contributions. We welcome questions and anything. Here are where we are. We are currently Jupyter Incubator project, eagerly looking to get to a Jupyter project. Documentations are here. The link for all the code that I showed today. And we look for us. We probably getting a release out sometime this week. We were hoping that we're gonna be doing that before the conference, but either the release or all the demo working, so we will opt for the demo. But yeah, thanks, and any questions, we are here to answer those.